First, I want to make sure the mic works. I've had bad experiences. Actually, I wouldn't call this mind-blowingly new. It's actually going back to the roots of the internet and go back over the last century. So I'm simply saying we're stuck in a mind-bogglingly old system now. So I talk about our new infrastructure, or much simpler, how to get more internet. There's something we want to get more of that we can't quite articulate. And okay, I've been held hostage by these people who've locked down all the Wi-Fi, which is really about the web, not the internet. But with enough begging and everything, they let me communicate. And communications is a central theme here, because part of the problem in understanding what I'm saying is that the very words we use implicitly assume we're in the 19th century talking about railroads. So when I use, in order to talk to people, I have to use words like broadband, but if I want to be precise, I have to explain that often these words, it's like when you say literally these days, you have to say literally figuratively or literally literally. Language is very interesting. So let's go down the rabbit hole. The internet is really a discontinuity from the past. Everything, we talk about pipes and all this stuff are the old paradigm. The internet is very different because of our devices. We've taken all the intelligence, all the things in pipes, all these things we beg people to be neutral about, and taken them outside the network. And that's worked very well. We need to understand why it worked in order to leave the past and actually take control of our ability to communicate. And the problem I have is neutrality is a necessary policy if we accept the idea that somebody controls the pipes. It's not enough. It's sort of like the days of separate but equal. It's better than nothing, but we can do much better than ask for neutrality. We can ask for control of our ability to use any means to communicate. And the word paradigm shift is cliche, but really applies because we're going through this major transition. And one thing I'd like to ask lawyers here, like Jonathan over there, how does the legal system deal with the situation when the defining premise of a whole body of law no longer is true? And our current policies are basically the policy of 19th century railroads. There's a book, Railroaded, by Richard White, which would be great to read, and it's very eerie because talking about railroads and the formation of the ICC, but you'll recognize he's talking about telecommunications. And the content inside the pipes is like trains on tracks. And telecommunications is based on making promises. We have to beg for each additional service. We have to ask for television, we have to ask for phone service. And one of the defining characteristics of the internet is none of the services are baked in. This is what's so revolutionary about it. It's basically a new paradigm. And the value is created, and this is part of it. One thing I point out, this is as much about economics as technology. Railroads, the value is created by owning the railroad. With the internet, the value is created outside. The rail owner doesn't get the benefit of the value created by rails. Even with the railroad, if you're carrying gold bullion, it's still just freight. It could be lead bricks. But and the other part is like the road system. The value is in a hole, which is one problem. We have a problem trying to make every wire a profit center, which is very strange. Roads. Imagine somebody shutting down your local street because it wasn't profitable. So, and this is the problem with broadband. The reason it's not a lot of towns, it's not profitable, but the solution is to fund the whole. And this is the thing we're going to be getting back to. But the first, okay, and by the way, this is a new set of slides, so if I seem to be practicing, yes, I put this together for this audience, but typically I'm speaking to more technical audiences. So in this case, I'm trying to sort of bridge the gap. But in order so the internet is really, given that we're not, phone service not baked in, we're only limited by what you can imagine. So in order to understand this, we have to look at the history of telecommunications. And basically we had the idea of the telegraph. The telegraph is a very nice idea. It allows to communicate over any distance, because digital signals could work over any distances. But it was also very much like railroads. A telegram is a state of freight, so you'd ask the telegraph company to carry a telegram. And even better, those long-distance telegraph lines ran along the railroad tracks. But again, part of the problem is talking about this because, like, how many people know what radio is? It's music. It's talk. If you try to talk about the radio technology, even a show like the Consumer Electronics Show, people get confused. Pandora is radio. This tubes, diodes, that's not radio. And because we communicate using telegrams, we use the same word for the technology of communications as for speech. And that is no problem if you're dependent upon a company carrying your speech for you. We even named the commission to manage this the Federal Communications Commission. And what do they manage? Speech. They tell you what words you're allowed to use. You know, how do we get from a company that's supposed to be managing telegraph wires and making sure they're fair to telling us what words we're allowed to use? That's because the word communicate has multiple meanings, and we need to distinguish between them if we're going to get our freedom to communicate in the sense of human speech, rather than communicate in some technical, autistic sense. So one of the things that I'd like to change is a talking telegraph. This is Al Bell's invention. Well, he stole from Elisha Gray, but we won't quibble. And what happened is, thanks to analog signaling, long distance became complicated and very expensive. Very hard to keep voice going over long analog wire. So we became very dependent upon the carriers to keep speech intact. Now the solution was basically invention, or not the invention, remember telegraph was digital, but the rediscovery of digital signaling. So now we can take a speech and code it as digits and carry it over any distance and perfectly preserve it. But as with any new technology, the first stage is substitution. So we think of all this digital technology, packets and everything, in terms of the old phone networks and 19th century railroad law. And now this window's okay. But you know, what did happen is the first thing is distance did become cheap. So we did see a benefit right away. And MCI ate AT&T. But we misdiagnosed the problem and tried to solve it, saying, oh, it's just like the railroads. We just need wholesale railroads and retail railroads. Or that's also called structural separation, which seemed like a great idea, but as it turns out, everybody remember when there were thousands, 7 whatever baby bells? They've all coalesced to the point that one even is an expert in identity theft. Because they bought their identity at garage sale in New Jersey. They used to be SBC. They now call themselves AT&T. Because the old AT&T basically got composted. But the other thing that happened is software is eaten the world. We can use software to redefine everything. And that's really the change here. Because in the old days, you built a phone system to carry phone calls. You build a system for each purpose. But once we have our intelligent devices, we can make them do anything. But then that's the other branch. So the outgrowth of all this digital technology had the side thing which created computers. This is totally apart from and unrelated, except for the accidental fact that a rich company that funded research could actually spin off computers on the side. And we just ran our own wires in the holes to exchange bits and packets between them. Very much do it yourself. And it worked even better in Hawaii, where there was a research project called the AlohaNet, which basically have radio packet networks over wire. Now, it was called a network, but it's no more a network than a social network is. You know, if we use the same term as social networks, we'd only have arranged marriages. So Now, the Aloha Net basically had no network. If something went wrong, you had to fix it yourself. So we learned, but again, with software, we can program around anything. We could basically get the message through even if we lost some packets. And my classmate of mine was sitting next to me explaining his idea of putting on Ethernet, basically taking wireless and bringing it back to coax. It's sort of funny when people talk about wireless as being new liberating. No, Ethernet was a wireless network recapture. But the bits don't care. That's what I'm saying. So the Ethernet is basically a wireless network into coax. The idea of having separate rules about wired, wireless bits, and wireless networks, it doesn't make sense. It's like separate laws for red bits and green bits. Now, what's interesting happened then is we went global. I mean, this idea of basically running our own networks around the office, putting all the computers on a wire, or radio packet networks was great. Why can't we connect all these networks around the world? It means fairly straightforward. And the nice thing, first the engineering problem is all we had were packets. In other words, in the old days, I wanted to bring a video network or phone network, you extended a phone network. But because all you saw on these local networks were basically packets, you couldn't make sure it was telephony. You couldn't assure that the phone call worked, you couldn't assure the video got through, and we had to learn how to deal with that. But the good news is we didn't have to run the wires. We can buy them. Or at least we can demand that the companies who own the wires sell us the ability to use them. But these were, I can say bad things about the companies, but they're not dumb. They knew that allowing raw packets to go through would be their end, and they were right. But this is where neutrality or common carriage is important. It forced them to allow us to use their pipes. So neutrality is a necessary policy if we're stuck within pipes. Point is that the internet, though, we're not stuck within pipes. We use those pipes to tunnel through telecommunications. But the internet itself, it has raw packets we exchange. And this is why I started with talking about language and jabberwocky, because it's very easy to get confused. Because with software, we can spoof things, but it doesn't mean we need the pipes. We're just forced to use them temporarily. But once we leave the confines of telecom, we don't need pipes. As a matter of fact, a great example is BitTorrent. BitTorrent will get a packet from here. Not only does it take, these two packets getting different paths, we can take the data from different places. It's a completely different way of thinking. By the way, that's another Stuyvesant graduate, telling Joe. So the fact that we learned how to deal with lost packets was very powerful because, as we'll see, Skype really went with this idea. But what was interesting is TCP, transmission, how many people know it? I should have asked at the beginning, how many people are lawyers here? How many people are geeks? How many people can build an IP network if they had to? Okay, I just want to know where we are. But so the importance of TCP is that it took all these unruly packets. Now, you do not have to use TCP, but if you want to basically have the convenience, in other words, you can program if a packet gets lost, resend it yourself. But getting that right on a local network is easy, very fast. But if you want to send a message from here to Paris, and in the old days, the network ran at a very high speed of 56,000 bits per second. So you'd have some capacity limits. So TCP was basically a protocol that said, it's not simply if you retry, but it said if things look like they're getting stuck, slow down, give somebody else a chance. This was a very distributed, do-it-ourselves protocol for cooperating. And despite all the prepper shows on TV, it's amazing how well basically distributed cooperation works with no central enforcement. Can there be bad players? Of course. But two things happen. One, most people are running the same software, so don't think of it. But the bad players immediately run to limits. It doesn't scale, and you learn right away that it pays to be a good player. And this is a social lesson apart from any of the internet. But it's also, we don't have to use TCP. If you want to risk losing packets, if you're doing streaming music, hearing a note 5 minutes later is not going to do you any good. So you want to have another policy who's better never than late. That's something that the telecommunication companies didn't offer because they couldn't add enough value to those protocols. So the situation we have now is that we have a single infrastructure in the set of the same physical wires, the same radios, we all use the same colors, but we have two different interpretations. And this is the important point to understand. There are two different ways to use the common wires. You have the telecommunications approach of pipes, a known to excluding people, as we'll see, and we have the internet. And the internet is not a layer on top. Layering is one of these engineering heuristics that's actually, it's good heuristic, but it's really bad engineering. Instead, we use everything as a resource. So the internet sees all the wires as a resource, potential resource, that they're smarter about how to use. So telecommunications, the owner has exclusive control over pipes, just like the railroads control their rails. The most important skill that a telecommunications company must have is the ability to prevent people from communicating. Because if they don't prevent people from communicating, they have nothing to charge for. And it's so easy to exchange bits, as we're learning with the internet, that if they don't prevent that, they're out of business. And the Skype shows they can't really prevent it. And telecommunications companies would have a enumerated service. You want a new service? No, you'd have to engineer a system. You might have to spend another $1 billion building new wires, and then you petition the FCC for that service. And eventually, maybe, possibly, you'll get it. But if you're an individual, forget it. The internet, on the other hand, is a way we use any available facilities. You don't get a lease line from this company, use it from another. This packet gets stuck here, send it to another. And you have to discover what's possible. And as we'll see, if we demand voice works, you're hostile to the voice provider. If you're flexible, you get freedom. The problem we have, though, is that telecommunications and the internet seem the same for people with very fuzzy glasses. They both do voice now. They must be the same. And then when we confuse the web with the internet, it looks like the web is just another television station. Even worse, when we think the web is the internet. We'll get to that. So traditional telephony is a good case study. It only worked, well, first, every element of the system exists just to support voice. You want to do something else, you got to throw away a $1 trillion investment. And we're throwing it away. And it's very brittle. If anything goes wrong, voice fails. But because by bad engineering means that you got to pay them a lot of money to keep it working. They have to work very hard to prevent you from communicating. They just make one mistake and it fails. So the service is defined by the network operator, and they'll tell you, anybody, well, I won't give you the answer, but when you place a call, when is a call complete? Now, the FCC will tell you when the other phone rings. Humans have a different interpretation. A call, well, it's ambiguous. A call can be complete when you leave a message. A call can be complete when the person understands the message. It's not defined in the network. And again, this is a language. We don't have to define what a call is complete because we're in control and we decide for each of us what we mean for that call. And we define what quality is. This whole idea of the network operator, quality of service, all these excuses why we need a phone company in the middle to make sure things work basically don't apply. So voice over IP is an interesting case because it didn't work on the early internet. Now, one solution is, as we said, we built a phone network just for voice. That's for those who know the term SS7, that was basically a special system for voice. But as a byproduct of the web, this is part of the problem. If you want to buy and pay for your own solution, you'll be stuck. But if you find an opportunity to take advantage of it, then you get the benefit. So the web provided a reason for increasing the capacity, and that made voice work. And then we discovered it worked quite often, which is very nice. And video also started to work, and often is much better than never. The phone companies couldn't do video because they couldn't guarantee it worked always, so they had to prevent it. Okay. So the network, okay, we went through this. Now, very important. The implementation of VoIP and everything is machine to machine. And in fact, the internet's always been IoT, or the Internet of Things. So, and the problem like here, when you have to give a password to go through Wi-Fi or whatever, that's not the internet. The Internet of Machines, machines cannot negotiate their way through all the telecommunications. So we need to talk about basically the ability of things to connect. This is, I know in the program we talked about ambient and borderless connectivity. I won't be able to go into it, but basically you want to be able to assume connectivity rather than having to sort of have the human at the keyboard making sure, okay, this works. Because the internet is about the machines that work on our behalf. Then we can do applications like the web which use it. So as I said, the current policies in Washington all assume telecommunications. As I said, the owner is in control. It also assumes very high capital costs, no differentiation, and facility-free service. The problem is that the regulatory scheme is all based on those assumptions. Now, so let's look at today's broadband. Well, this is not very different because if you look, my slides disappeared. These nice pictures of, well, I'll show you then. If you look up on the poles, you will see lots of wires hanging everywhere. And even to the point, it's annoying. They're beautiful pictures, but I'll get to them. Basically, that wire from the 19th century, we bundled them up and even put them on fibers, but inside is still the same mentality. If you look up on the poles outside on the streets just down here, those of you do your own networks at home, in the old days, you'll screw each network wire into a jack. That's all up on the poles. Everybody has a separate wire or network connection going to the house. So it's a very expensive analog infrastructure. Totally absurdly expensive, redundant, because if you have two broadband carriers, you've doubled the costs, only one times the capacity. But it's worse because it's a natural monopoly like electricity. The difference is electricity, at least you're selling something. You've got something of value. With the internet, you're just carrying bits, zeros and ones that have no intrinsic value. How do you charge for zeros and ones, especially when you're really carrying ideas? You know, this bit might represent something very valuable, or you might cache it. The example of BitTorrent, the bits might not go through this path, they go through another path. If it's cache Akamai, it's so different that the very idea of charging for speech, even if you thought it made sense to charge for speech, it doesn't work. That's why the internet interpretation and today's policy sort of killed it. But it's not a sustainable business model because you own an asset which has no intrinsic value, where there's no differentiation. When my Comcast connection went down, I plugged in my backup. When Verizon went down, I plugged in Comcast, no change. So one source of change is going to come from business. That the business of broadband isn't viable. If the city becomes a broadband provider, just like the old telcos, it doesn't really change anything. And worse with broadband, one thing I forgot to mention, again, I'll ask a rhetorical question. If you have a city with 100% broadband, okay, with 100 megabits to every house, on the average, when you walk around the city, how much capacity do you have? Any guesses? Anybody want to do the math? Nobody? 100% of the people have 100 megabit connections. How much connectivity do they have? 0. Because the square inches of the one jack you can use is almost nowhere. So for every person, they have connectivity in only one place. On the average, there's no connectivity. You're disconnected almost everywhere. And even when you're connected, you're only connected if this brittle path works and if you have a human to keep logging in all of this. So that's the paradox of broadband. But I'm going to use the term broadband, because people know it, but you have to understand that the pipe model of broadband is limited. I should also mention that, anybody recognize this chart, engineers? Okay. If you thought there was no meaning inside the wires, well, the problem is we've taken these we've created magical wires out of colors which don't exist. So according to this, there'll only be 7 people in the room, because the more there's 7 people in the room, I get confused because there are only 7 shirt colors possible, and then you get interference. Makes as much sense as this. So I pointed out broadband, economics of broadband do not work. You have nothing to sell, you have no differentiation. The defining principle that we need to basically create virtual train tracks in the sky doesn't apply. So if somebody wanted to, attack the FCC's legitimacy, it's easy, except for the courts. Remember, we have a Supreme Court now which thinks corporations are people, so all bets are off. So we need new policies for the new paradigm. The value is created by using the facilities and service created outside. We want to create. People say the internet is a utility. The problem with the term utility is electricity is a utility. It implies there's an ongoing charge ascribed to a service. I much prefer the word infrastructure. The internet is a way we use any available copper, glass, radio, just like we want to get from point A to point B. We can use any street, road, path. We can buy a Hummer if you want to drive over things. You can buy a pogo stick. It's up to you. So infrastructure is an opportunity and a resource. So the way it's just as the basically the ICC gave way to the Department of Transportation because people on pogo sticks don't fit in the ICC model. The FCC, we need a Department of Connectivity. So that makes sure we have available connectivity rather than regulating, I don't know, does communication mean speech? Does it mean pipes? Let's not worry about it. Let's just restart. But change is not going to come from the FCC one day waking up and says, we don't make any more sense. Let's go away. But the end goal should be indifference to the packet rather than neutrality. The road is indifferent to what's in the car. Now, we might have laws saying what you're allowed to do with cars, but the roads themselves are just a platform, physically. Now, part of this is we have to look at a lot of the business model. We're competing with the new telecommunications business model is cable content, because that's where the money is. You look at the fight over Comcast with Time Warner Cable. But we know, and Comcast knows, they do not need to own the wires anymore. So that's why Time Warner spun out Time Warner Cable. This is not a thing we have to explain to them. They understand that. What we have to do is explain to people in Congress and the people who vote. And Comcast, as I said, they've shifted the money to NBC Universal. They were leaving the cable. The only reason they want Time Warner Cable is they got spooked by things like Google Fiber giving other people pipes. Let's see. So standalone cable, I don't know. See, this is the nice thing about doing new slides. Sometimes I have a great idea at night. But the important point about separating the content business, the business of what we do with the physical infrastructure, and the infrastructure itself that avoids the conflict of interest. Earlier I said the only reason we were able to send packets to the phone network is the common carriage forced us to allow it. Problem is that neutrality is not strong enough to give us opportunity, because I don't know of any neutrality proposal that says that cable companies have to give back the 90% of the capacity that's totally off the table. Being neutral on the remaining 10% of the capacity is not enough. We have to have the business delivering content and the business of the infrastructure totally apart. That means funding. Now, for cable, their future is basic content brokering. In other words, that the future of cable is bundled, like HBO and CBS have already said they're going to follow Netflix and not going to depend on the cable. The over-the-top business model depended on owning. There used to be, do you remember days when, like in the South Sea Islands, you have these big stones to show you on money, and that model was adopted by the record industry, that you had to have a plastic disc to show you owned the right to play music. Today's versions, you have to have a cable coming in your house merely to show that you have the authority to watch HBO. That's going to go away as we become, detached. And that means we need a funding model for the infrastructure where we fund the infrastructure as a whole, like we fund the streets and sidewalks as a whole. You don't just pay for the street in front of your house. And that's starting to happen. So one example I have, which is nice, but it's in New York, is Castle Village in Upper Manhattan on Cabrini Boulevard. There's 600 apartments in 5 buildings. They each have 100 megabit Ethernet connection. That's an arbitrary cap. They could have said whatever number they wanted. Instead of paying $50 a month, they pay $10 a month. They get Wi-Fi in the common areas, and they all share 200 megabits on a gigabit fiber, which can easily be increased. This is, these are just numbers. And let's say these aren't cord cutters. Let's say everybody want to be a cord cutter, watch high definition Netflix. Well, Netflix should just put a caching server in the building. They don't have to run it all over the pipes. There's so many ways to solve this. But basically, the board wanted cheap internet, and they had an in-house geek who could help, but they were going it anyway, and Panics locally in New York as a provider. What's interesting, the next step to expand the footprint. So some buildings nearby that are already expressing interest in joining in. But one nice thing about negotiating is you don't have to even have adjacent buildings to get negotiating power. What is important, and I should actually, one thing I should back up to explain what I did when I was at Microsoft. In the 1990s, everybody was basically going to get, broadband is a fat pipe owned by the provider. They were going to give you an internet connection just like they gave you cable TV. Instead of a set-top box for the TV, they'd have a set-top box for the computer. And you'd pay a monthly fee for each computer. You wanted a printer, your monthly fee for each IP printer. You wanted a webcam. Sorry, that's not allowed under the terms of service. And as Excited at Home showed, they can enforce that. When I was at Microsoft, I put the router between the house and the provider, and they could no longer look inside. That pipe, which had meter reading and all these services, suddenly became just a bit path. They couldn't charge you for what you did with it. And I call that, and basically a home became a connected zone. I call that do-it-yourself networking. The reason we're stuck there is we need to take the leap to what I'm calling do-it-ourselves connectivity. But that's not a big leap. Because once you start to see your neighbor's apartment house, not simply getting connectivity that's cheaper internet, but also your devices. This is the Internet of Things. You want to put up, a temperature sensor for energy savings. You want to put up, one example, a camera to see what mail comes for you. You can just do it now. You don't have to go through this complex setup in order to take advantage of connectivity. So once you see these examples, just like Excited Home tried to get people back in the old model to pay per connection. They failed because people have seen all the neighbors who just had internet connectivity throughout the house. Once you see these kind of buildings, you start to see models, and that drives change locally. The important thing about apartment houses, whether it's landlord or condo, is tenants are stakeholders. They pay for it, but you don't have all the government overhead. You don't have to convince everybody. A landlord can just do it for the building. But once you see such examples, instead of starting to become a broadband city where you're repeating all the old telco models, you lock it down, and all broadband is good for the web, because devices can't assume connectivity. I walk around with this watch, it won't work unless I've got my phone. If you've got, could start to assume this open, borderless connectivity, it'll work everywhere. And this watch is a medical monitor, and if it can work everywhere, it'll save lives. So it's not just freedom of speech, this is freedom to save your life. A doctor can implement these medical services. So this is why the new model is important, but people are not going to adopt it, even if broadband economically doesn't make sense, even if the FCC's legitimacy is questionable. What's going to drive the process are examples of basically people owning their own connectivity at their edge and doing it as communities, starting with apartment houses and growing out to cities after they've seen those examples. So, this is taking longer, people want lunch, but does anybody want to have any questions? You could ask. Or you can say you want to eat. You can say what's for lunch.
Yeah. Takes a moment to warm up. Yeah, we're running late, but should go out for lunch because it's good to eat food.
Or something.
Yeah, or something, or whatever. Quick observation here. I live in an apartment complex where the landlord provides the internet access, and
But it charges you for?
they raised it around $100, and I was paying $100 before, so it's theoretically free.
Is it included?
Yeah.
Those examples are one, so we should talk about it.
Right.
But that's my point. Is that these Casperville is not the only example.
No, but my service is not good. I have no choice.
Well,
so they go through Time Warner, as it happens, and they've barred other providers from providing internet services, wired services on the apartment complex.
Then that's more we need to talk. What business I'm trying to start is to give you an alternative. The problem is that's not really open connectivity, because they're just the landlord in that case is simply selling you off to the highest bidder.
Yeah.
And is not in control. The real transformation comes when the building as a whole is a connected zone and it's just part of the environment. And just as important is when they aren't just at the mercy of Time Warner, but basically can negotiate for real service. And I've had the experience when my cable or Flyers goes down, and they say, we're going to rush right there. It's Friday, we're going to be as soon as we can, sometime on Monday maybe. Fortunately, I'm able to take some control myself, but if your building has a scale, and with the new technologies, your super can help. You can be much more responsive. And if we really say this is infrastructure, there is no excuse for not simply them rushing to fix it, but they should tell you ahead of time, your connection is getting flaky, and metering is told that we've already fixed it for you.
Right, okay.
I live in a, I should use that.
Oh, one thing, by the way, I didn't mention the talk, and this goes to the free press. Billing is the ability to control. If we have infrastructure, can assume it's there, we take away basically the presumed ability for prior restraint of communication. That's why the FCC's legitimacy needs to be questioned. But as we start to have borderless connectivity, the assumption is that we can simply communicate before we have to first convince somebody that our speech is worthy. Our speech does not use any dirty words. And we don't have to identify ourselves. So this is more reason for taking an infrastructure approach rather than a pipe. Without a pipe, where do you put basically the Santa Claus demon who distinguishes good from evil?
Yeah, I live in a building with 112 apartments, and we have an intercom system that goes from the lobby that we own to each apartment. And it works sometimes it doesn't. You call the super, you call this one, you call that one. So the quality of service in certainly a building my size is well beyond what our corporation, it's a co-op, is able to handle. So I don't see how how it's possible.
Okay, first, the answer is you hire professionals, not amateurs at the phone companies who basically recycle 19th century railroad people. In your house, when you turn the faucet and you flush a toilet, did that work?
Most of the time.
Okay, but that's a lot more complicated. Keeping the halls from collapsing, a lot more complicated. Keeping the bits moving is the simplest thing. What makes it hard is when you have people who make the money by preventing you from communicating and only grudgingly allow a few bits through. Those of us who understand this stuff, who've been working on it. Okay, again, story about home networking. When I did home networking, imagine, I said people can operate their own home networks. It seemed impossible in 1995. I started removing anything that makes it hard. And the longer talk I gave, and if you look at the beyond neutrality thing, I started to talk about new protocols which are far more resilient than today's protocol. We're still running on recycled trolley tracks instead of basically having protocols that take killers. So those intercom you said is flaky. Well, if the bits can go through any path, then wire to wireless, it becomes resilient. It's not dependent upon this brittle wires, and those wires as a common medium where packet go, and any wire that works anywhere can use any radio, much higher chances of working.
So those 6 buildings that you were pointing to on Hudson and wherever that was,
yes,
that's an existing system that's working?
Yes, Cabrini
and it's
Boulevard.
Operated by the co-op?
It's operated by a combination of the co-op and Panex, yes.
All right, good.
I'm very interested in your ideas. As you know, I'm skeptical of some of them. And Alex Goldman.
I'm just trying to get
I agree that the FCC is a mess, that the current regulatory system is in trouble, but I do think that you need infrastructure of some kind. Now, it's certainly true.
No, we need infrastructure.
Right. We don't need necessarily the current system. And I used to live at Castle Village too. I've moved to Queens since.
Wait, live where?
I used to live at Castle Village.
Okay.
And I was there when Verizon CLEC built the system that's now in operation there. It was built by Verizon Avenue. Verizon had a very uneasy relationship with its CLEC, and I'm not surprised that Verizon isn't operating that system anymore. But if I recall, it was Ethernet to the D-SLAM. I mean, copper to the D-SLAM, and then high-speed fiber up the elevators, and then
I'm not
fibers.
Yeah.
Yeah. And then all of that takes money to build. Now, I suspect that you have an idea that you haven't given to us, in which there would be local ownership and management of the internet built from the bottom up.
Yeah. Well, okay, so I explain. I can give a brief version of it.
Yeah.
The first, Cabrini, I don't know, they might have rewired it, because you look at, one question is a cost-benefit trade-off where they put new wires, use existing wires. And in your home, one thing Verizon has done, divestiture gave people control of the wires in the homes. There's some ambiguity, but Verizon uses RG6 in residential so they can poach Comcast cables. So you can run over sort of any kind of physical infrastructure. I mean, there are so many options. And in your home, in the 1990s, structural wiring was to be fiber and coax to every jack. Turns out Ethernet runs on copper wire. When you have the right incentives, it's amazing what you can do with existing copper. We run 10 gigabits over copper in the home. So there are 2 parts to this. One is in terms of the current cost and stuff. There's a significant expense, but Verizon already paid, if you think of the stuff Verizon put in these houses, or Time Warner, whoever, think of that as a loan you can never pay off. There's a fixed cost of the infrastructure. The only quibbling is Do you finance it and pay it off one day, or do they finance it and you can never pay it off? This is extreme payday loans. Longer term, I do argue the costs are going to go way down as we learn, we basically align incentives. Right now, for those who have flown recently, you notice all your planes are full? The airlines have learned how to be profitable by creating scarcity and creating all sorts of fees. The phone companies do the same thing. The only difference is I'd have a better idea for airlines, but there's no reason to have such. Okay, no, I think this is why I'm saying. There's no reason for having scarcity for connectivity. In fact, if you align incentives, you get the Moore's law effects. Okay. If you align incentives, you start to get the Moore's law effects, which has taken our homes from the 1990s when we had $200 2400 bit per second modems to $50 gigabit switches, which can all be managed. And that's a 1,000,000-to-1 ratio there without even trying. DSL, copper wire, 25 years or Moore's law to catch up on. Now, we have to be careful. Fiber mongers have a stake in saying rip it all out and put fiber in. But if we just line up the copper initially, you get a lot, it's amazing how much you can do already. So, it's cheap enough to basically do what a building does, put clean fiber in, everything. It's it's part of the operating costs. But over time, we can repurpose all the existing wires in the building. So initially, yes, you do a high price thing like Verizon did, but it's a loan you can pay off.
I've got one. So, we had, what we have here in the US is facilities-based competition. That's the system,
Not really.
in
We have
contrast-
FCC synthetic competition, pretend competition.
But in contrast to the kind of unbundling that goes on in European countries and, in places like Korea and Hong Kong where there's one system.
Yeah.
No.
So I can show you pictures. I was just in Korea. The poles are just like us. Wires that say LG on the pole, wires that say Samsung on the pole. And we have Sweden where there is a common infrastructure. For some reason, they have a common infrastructure, and you explain why they now say, okay, we're going to put a wall around it just so we can create fictional ISPs to collect money and limit you to communicating only in your house.
So what I'm trying to get at is, do you see some kind of move back to the kind of unbundling model? Because if you've got pipe going into your house, do you see everything coming down the general purpose internet, or do you see something like a carrier hotel, an open access carrier hotel at the end of that pipe, so that you can
Okay,
connect
this-
to the
okay.
service provider of your choice?
Okay, this is a longer whole talk in itself, but let me try to give a simple answer. You've got copper, you've got glass, you've got radios. Use any combination you want. The city will hire people. If you have a new city, you'll hire people to run probably fiber because it's so cheap around the neighborhood. And then let's say you want to connect to the fiber nearby. Well, initially you'll have a radio link. You'll get maybe 100 megabits over the radio. Let me finish the model with the radio link. And then if you want to pay more, you can, it's like a driveway. You can upgrade it.
But what will you connect to?
Well, that's a discussion. What do you mean connect to? When you get on the road, what do you connect to?
Well, you can drive to any destination.
Yes, same thing. There's just a physical material basically, you'll be able to send bits to any destination in the world. You'll connect to any. Again, this problem is this is already been a long talk, but I'd explain more detail. You connect it to another machine. When you do something, I've got machine A, machine B. You're connected to the machine. The stuff in the middle is just, basically helps facilitate. But if you got a powerful radio, and especially with sped spectrum, so you don't have to worry about all the nonsense about divvying it up. We did one experiment with a 25-watt radio. And
I'd like to hear Joe Plotkin's comments.
well, let me
on
just finish this comment on the radio. That radio worked well over 2 billion miles. 25 watts at a couple of kilobits per second. It's called the Voyager. Now, we had a big antenna here, but just shows you the extreme case. And that 25-watt radio has passed the orbit of the planet formerly known as, as the object formerly known as the planet Pluto, and it's still transmitting. So we can do a lot with the radio, but you know, you want low energy and make it simple. You hire somebody in the middle to relay the packets, not relay the message like a phone company does, relay the packets, and those can take any means you want, any combination. You know, people talk about, we're a fiber company, we're a couple. That's nonsense. Any mix and match works. And more than that, instead of the single brittle path you have with miles of wire going back to a central point, you'll go to any point. And there's no, you don't need any hub because it's all peer connectivity. As with BitTorrent, it's all very distributed. Today's protocols aren't good for that, but that's a separate discussion. We start with today's protocols just like we started by recycling a phone network, and then we do a native, much more distributed approach. So the connectivity within any particular house or building is first-class connectivity, just like to the rest of the world.
As you know, Bob, I'm a big fan of your ideas, and makes us think outside of our copper boxes, copper cages.
Well, no,
I just like to.
wire.
I'll just sort of.
Just go
Yeah,
ahead.
there shouldn't be. We should have much more open spectrum. But beyond that, I'll just reframe what you said, which is the problem we have right now that we have to get past is that we've ceded to private corporate interests the connectivity that you talk about. So they're extracting money from us, but the society has much greater value on that connectivity than they could even extract, and they get value by blocking that connectivity. So I think that we're starting to see with the fight over net neutrality and 4 million people actually submitting comments to the FCC, that the thing that Bruce and all of us have been fighting for years of this severe monopolization of our communications infrastructure, privatization of our communications infrastructure, that their goals and the societal goals are different, fundamentally different, and they always will be. And we have to recognize in this country that until we do some sort of public infrastructure like you're talking about, until we get there, we're always going to be fighting this fight, and we're always going to be on a losing end.
But let me say it a different way, because I want corporate interests involved and happy. I just want to align the incentives. The problem now comes down to economics. As long as we finance our infrastructure as a profit center by having an exclusive owner, that's the problem. It's an economic problem, not a technical problem.
Correct. We're in agreement.
Okay, so, okay, and that, I just want to emphasize that it's economic. I'm trying to avoid the moral argument. That's what I'm saying. And I worry, the other fun thing, I worry about focusing too much on neutrality in gigabit cities locks us into the old model. We have a new boss who acts just like the old boss.